More examples on how to use logarithms to solve equations. So once again, I start with this strange looking equation that has an exponent of 2x. There are some basic things that I can do. I can move this 1 across to the other side. So I've got the 1/4, 4 raised to the 2x. You cannot multiply when you have that exponent present. So I bring the 1 over. 5 minus 1 is 4. Then I can multiply by 4. So this would be 4 to the 2x is equal to 16 because I'm multiplying both sides by 4. Now technically when I'm looking at this one, I could solve this using the first couple examples that I used where I have like bases, because I could turn this into a 4 squared. And I'll tell you right now x will be 1. Because if 4 squared is equal to 4 to the 2x, x has to be 1. But I want to go through the process of using a logarithm. I want to pretend like I didn't understand how to solve that. So once you get to this where you have a base exponent equaling a value, that's where you can invoke your logarithm. And so you could say the log of 4 raised to the 2x is equal to log of 16. Now because I have that argument where I have an exponent, I am allowed to bring that out as a multiplier. So I can go 2x log 4 is equal to log 16. And then recognize that the log of 4 is just a number. So I can divide both sides by log of 4. And I got this 2x equals log 16 over log 4. I can go to my calculator. You're almost always going to have to go to your calculator to do these. So I've got the log 16 divided by log of 4. And it's giving me a value of 2. So 2x is equal to 2. And kind of as I predicted, when I divide by 2, x is 1. If you weren't following that prediction, look, I've got 4 to the 2x. And 16 just 4 squared. So I could drop the bases and say 2x equals 2, so x is 1. And so it's always nice to have something in your back pocket where you can solve that. I'd like to do another example. And this one I'm going to make a little bit more complicated. We'll call this example 8. And so for this problem we've got 2/3 e. E is just a number. Raised to the 5 tiger minus 1/7 equals 9. You start off with the same transition. You can move some numbers, you can do a little bit of algebra, you want to do that. So I'm going to say 2/3 e to the 5 tiger equals, I'm simply going to move the 1/7 over. 9 plus a 7th is 9 and 1/7. And then the next step, I need to get rid of that 2/3. So I could divide both sides by 2/3. And so I get e to the 5 tiger equals, I'm going to put that in the calculator. Let the calculator do the work. That's what we got them for. So I'm going to do my alpha y equal, I'll do 9 and 1/7. Divided by 2/3. And it tells me 96/7. Now, the next step, I can natural log both sides. If I do a natural log, you notice in the examples I keep going back and forth. A natural log and a e, let me show you something in the calculator. Those are inverses. So if I do natural log and then I do my e, the e button is the second and then you hit natural log. And I say 5. It gives me 5. Now, I'm going to change that exponent and maybe I'll say 12.3. It gives me 12.3 because it undoes it. The natural log undoes the e and the e undoes the natural log. So whatever you have as your exponent just comes out. that's what would happen here. If I do a natural log of e to the 5 tiger, then you have to natural log the other side, 96 over 7. That would just become 5 tiger. You don't have to memorize that, that's fine. You can still do it the other way. You can do this. You can do your power rule, argument to a power, and say this becomes a scalar. Ln of e equals ln 96 over 7. But my point is that e is raised to the first power. This just goes to 1. So if you go and divide this, it's going to give you the same result as if you just did natural log of 96 over 7. But I don't want to change our format, so we can do that, make you comfortable there. And then I have to put that in a calculator. So I'll do natural log of 96 divided by 7 divided by natural log. Now your e would be the same thing. You're just going to go second natural log, as I explained a moment ago, but you do have to say it's raised to the first. It doesn't like when you don't have that value there. And so that gives me this goofy decimal. You'll quickly note that we are going to have decimals for our answers. And the last step would be to take my value that's in the calculator and divide it by 5. And so then I say t is equal to 0.5237. I'll round to the 4th decimal place. And so there's 2 more examples. Really, it's just an introduction of how to use that logarithm or the natural log to solve equations. And I'll do a couple more examples just to make sure you're feeling comfortable before I assign the homework.